Hi everyone. So today we're going to work on our first part of our basic concepts of probability. So we want to introduce some terminology, take a look at how to find some basic probabilities, but today we're going to focus on what is called a sample space and the fundamental counting principle. Both lead us to how to find probabilities, which we're not talking about, like we're leading up to finding that probability. So the first term is probability experiment, which is an action or trial through which specific results, such as counts, measures, or responses, are obtained. So rolling a dice, you're counting. Asking people a question, you're getting a response. Measuring the number of, or measuring the height of a basketball when thrown, that these are all experiments. The outcome is the result of one trial. In other words, one time doing it. But when you put them all together, like let's say I'm going to roll the dice 36 times, then all of the results are in what is called a sample space, which is the list of all the outcomes in the experiment. Now, an event is a subset of that. So if I may be looking at, if I'm rolling two dice and I'm doing it 36 times, and I want to know how many times do I get a sum of 3? Well, the sum of 3 would be an event. It may contain no outcomes, one outcome, or more outcome, one or more outcomes. All right, so let's take a look at our example here. We're going to write a sample space. All right, survey consists of asking people their blood types, which is O, A, B, and AB, including their Rh positive or Rh negative factors. Determine the number of outcomes and write the identify the sample space. Now, you don't have to do that in any particular order. I find it easier to determine the sample space and then state the number of outcomes. Okay, so when we write a sample space, we usually write it with braces, okay, these like set notation concepts. And I'm just going to list it. O, and you can be O positive, you can be O negative. You can have A positive, or you can have A negative. You can be B positive, or you can be B negative. You can be AB positive and AB negative. And those are all the possible outcomes. So there's 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Okay, so we want to list the possible outcomes and state how many there are. A probability experiment consists of tossing a coin and rolling a 6-sided die. Describe the sample space. Okay, so we're going to toss a coin. So that means you're going to have a head or a tail. Now I'm going to do what is called a tree diagram to help me figure this out. Okay, and then I can roll a 6-sided die. I'm going to need more room. Okay, so let's do this. I'm going to need more room. Okay, so when I get a head, I can get a 1, 2, 3, 4, 5, or 6. When I do a tail, I could go 1, 2, 3, 4, 5, or 6. My tree diagrams aren't exactly looking like trees. Sorry. And so I can put them together and go, okay, I can get a head and a 1. H1, and then I follow through. H2, H3, H4, H5, and H6. And where I can get a tail 1, tail 2, tail 3, tail 4, tail 5, and tail 6. Okay, so there are 1, 2, 3, 4, 5, 6, 12 outcomes. Okay, so you can make a list or a tree diagram, whatever makes most sense to you. I'm not very good at tree diagrams. I like making a list. But sometimes tree diagrams do a real nice job of visualizing what you're trying to find. All right, why don't you pause the video and see if you can do the next one. I may be wrong in the next one, so we'll have to talk about this one in class. All right, so it's the probability experiment according to the response to the survey and then the gender of the respondent. So I looked at it and went, okay, there are 3 here, yes, no, and not sure. And depending on your thought on gender. Okay, so I have yes and male, yes and female. No male, no female. Not sure male, not sure female. Yes, transgender, no transgender, and not sure transgender. Now, I am sure there are more thoughts on gender So if you could add in whatever thoughts you have, or if you have others, please let me know, and we can discuss that in class. I think this is one we're going to discuss in class. Now, if an event only has one possible outcome, that is called a single event. So that's kind of important because that kind of helps you narrow down like your probabilities eventually. So we want to decide whether the event is simple or not and why. For quality control, you select a computer chip from a batch that has been manufactured that day. A is selecting a specific defective chip. So I'm choosing a very specific defective chip. So this has one outcome. Okay. All right. So because it's a specific defective chip, I'm only looking at one of them. Okay, we roll a 6-sided die, and the event is rolling at least a 4. So at least a 4 means you're doing 4, 5, and 6. That has 3 outcomes. So this is not a simple event. Okay, this was a simple event. Okay, pause the video and see if you can identify the next 2 as whether or not they're simple events. All right, let's see how you did. Okay, so the A, I have no, because you can be 18, 19, 20, 21, 22, and 23. And then B, I have yes, because it's only 20. All right. Now, so let me know if you have any questions. All right, so far, sample space is all the possible outcomes. We make a list of those outcomes, and then we can look at part of those outcomes looking at a specific event contained within those outcomes. All right, so the counting principle helps us determine the number of outcomes for a sample space. And the way it's read is that if one event can occur one way, we're going to call it M, and a second event can occur N ways, a different way, or the same number, it doesn't matter, then the number of different ways both events can occur, one right after the other, is M times N. And this rule can be expanded for multiple things, so you don't only have to have 2. Okay. So the counting principle is along the lines of like how many different ways can you order a pizza with crust, sauce, and let's say veggie toppings and cheese. Okay, so one of my best friends in high school, he worked at a pizza shop, and we would always go over there like on Friday nights and eat all the leftover pizza. So we could get thick or thin, or it's basically thin Sicilian or stuffed crust, and then you can have white sauce or red sauce, and then you could have like bacon and mushrooms and like a variety, and we could figure out how many different ways you can get a pizza. Well, that's what this is. So let's take a look at this. So you're purchasing a new car. The manufacturer's car sizes and colors are listed in the table. So you can get a Ford, GM, or Honda. You can get a compact or midsize, and white, red, black, or green. How many different ways can you select one car, one manufacturer, and one color? Now, you can do a tree diagram here to check and make sure like that's why it works the way it is. But according to our fundamental counting principle, we're going to take the number of manufacturers times the number of car sizes times the number of colors and determine there are 24 different ways that you can create that car. Let's try another one. So all we're doing is multiplying. I like to think of this as number of choices times number of choices times number of choices. How many choices do you have for each part? Okay, so the access code for a car security system contains 4 digits. Each digit can be any number from 0 to 9. How many different access codes are possible? When? All right, now think about this, people. 0 to 9 is 10 numbers. Okay, there are 10 digits. 0, 1, 2, 3, 4. Okay, not 9. So it's not about the numbers themselves, it's how many of them are there. All right, so each digit can only be used once and not repeated. So I like to think of these as like slots to fill. All right, so here's our 4-digit number. And since you have 10 choices for the first number, we get 10. But now once I use that number, I can't use it, and it says only once and not repeated. So I can't use that number again. So now I only have 9 choices. Use that number, now there's only 8. And then use that number, and now there's only 7 choices left. So we're going to multiply 10, 9, 8, and 7. So we're going to get 540 different ways that we can create that security system. All right, well, what happens if we can repeat those numbers? Well, again, I have 4 choices, 4 slots to fill. I have 10 choices, 10 choices, 10 choices, and 10 choices. So we get 10,000 different ways that we can create that access code. All right, let's try this one. Each digit can be repeated, but the first digit cannot be a 0 or a 1. Okay, again, 4 slots to fill. Can't be a 0 or 1, which means I've limited my number of choices for the first digit down to 8 possible digits. But the other 3 can be all 10. Okay, so that's 8,000 different choices. Okay, all right. Pause the video and try the next ones. All right, let's see how you did. We have license plates here. It consists of 6 alphabetical letters. By the way, I hope you all know that there are 26 letters in the alphabet. People ask. All right, each of which can be repeated. So, if you can repeat, then there's 6 26s. Now, this is not 6 times 26. It's 26 to the 6th power. Number of choices times number of choices. There are 26 choices, and we're doing it 6 times. So there's a 308,915,776 different ways. Now, this one says, what if we cannot repeat? Well, there's 26 choices for the first letter, but then you get 25 because I've already used one, 24, 23, 22, 21. Multiply all them together, we get 765,600. Now, keep in mind, this is most license plates. All right, 6 letters of the alphabet which we can repeat it, but the first letter cannot be A, B, C, or D, which means that I'm down 4 letters, which means there's only 22 choices for the first letter. So 22 times 26 times 26 times 22, okay? 261,390,272 different license plates. 1 digit followed by 5 alphabetical letters, each of which can be repeated. So we have 10 choices for the first one, and then followed by 5 26s, 106,932,384 different license plates. Okay? All right, let me know if we have any questions, guys. And I hope you have a great rest of your day. Talk to you again real soon.